Hi, welcome to this video on Algebra Revisions. Here we are going to go through some of these exam questions. Question 1 says, solve the equation 2 over 3x minus 4 minus 1 over 2x plus 1 equals 1/2 and give your answers correct to one decimal place. Here we have an algebraic equation involving three fractions. First, we must find the lowest common multiple of these three fractions, and in this case our LCM will be 2 by 3x minus 4 by 2x plus 1. We're going to multiply all three terms in our algebraic equation by the LCM. When we do that, some simplifying will happen. When I multiply the first term by the LCM, 3x minus 4 will simplify, leaving me with 2 by 2x plus 1 by 2. Subtract. When I multiply this term 2 by the LCM, 2x plus 1 will simplify, leave me with 1 by 3x subtract 4 by 2. And then finally, when I multiply term 3 by the LCM, the 2's will simplify, giving me 1 by 3x subtract 4 by 2x plus 1. Now we're going to multiply it all out. First off, I'm going to go 2 by 2, which is 4, and then I have 2x plus 1 minus 1 by 2, that's minus 2 by 3x minus 4 equals 1 by 3x minus 4 is still 3x minus 4 by 2x plus 1. Okay, 4 by 2x gives us 8x, so 4 by 1 is 4. Negative 2 by 3x is negative 6x. Negative 2 by negative 4 is positive 8. Equals 3x by 2x is 6x squared. And 3x by 1 is plus 3x. Then we have negative 4 by 2. X is negative 8x. And then we have finally negative 4 by 1, which is negative 4. Let us see what we can simplify now. On the left hand side I have 8x subtract 6x is 2x. Positive 4 plus 8 is 12. And on the right hand side, 6x squared cannot be simplified. 3x minus 8x is minus 5x. And I have my minus 4. Okay. I'm now going to bring what's on the left hand side over to the right hand side to give me 0 is equal to 6x squared minus 5x subtract 2x minus 4 minus 12, which gives me 0 equals 6x squared minus 7x minus 16, which is the same as 6x squared minus 7x minus 16 equals 0. Now we need to solve this quadratic equation 6x squared minus 7x minus 16 equals 0 to give the values of x that satisfy the original equation. Now, we have two ways of solving equations. We can factorize and then let both factors equal 0, or we can use the quadratic formula. Now, there's a hint in the question. It says give our answers correct to one decimal place. This would indicate that we need to use the quadratic formula. So that's what we will do. The quadratic formula says x is equal to minus b plus minus the square root of b squared minus 4ac all over 2a. I'm just going to rub out this here revised pages. So let us write down what we have. We have a equals 6, b equals negative 7, and c equals negative 16. So we're going to sub that into our equation. X equals minus b minus 7 plus or minus the square root of b squared minus 7 squared minus 4 times a, which is 6, times c, which is negative 16, all over 2 times a, 2 by 6. And this will simplify to give us x equals 7 plus or minus root 433 over 12. We can then use our calculator to evaluate this, giving us x equals 2.3 to 1 decimal place, or x equals negative 1.2 to 1 decimal place. This then moves us on to question 2. Question 2 says, find the values of x which satisfy 2 bracket 3 plus 4x, closure brackets, less than or equal to 22, where x is an element of natural numbers. Here we have an algebraic inequality. X is a member of natural numbers, which means x must be a positive whole number in the solution set. So, to solve this or find the values of x which satisfy, we first remove our brackets by multiplying 2 by 3, which gives 6, and 2 by 4x, which gives 8x, less than or equal to 22. Algebraic inequalities follow the same rules as equations. We can bring our 6 to the other side, i.e. subtract 6 from both sides to give 8x equals 22, subtract 6, therefore 8x equals less than or equal, 8x is less than or equal to 16. Now we divide both sides by 8 to get x less than or equal to 2. So x is less than or equal to 2 and x is also a natural number, therefore x can be 1 or 2. This now brings us on to our next question. We want to solve for x and y the simultaneous equations 2x minus y equals 1 and x squared minus xy equals negative 6. Here we have one linear equation and one quadratic equation. We have to use the method of substitution in order to solve for x and y. This takes the following method. We first take the linear equation, 2x subtract y equals 1. We get this linear equation in terms of one of the variables, i.e. either x or y. In this case, I'm going to bring my 2x to the other side of the equal sign to give negative y equals 1 minus 2x. I'm now going to multiply by minus 1, so I get positive y is equal to 2x minus 1. I now have y in terms of x. I now take this equation and sub it into my quadratic equation every time I see y, giving me x squared minus xy, well y is equal to 2x, subtract 1, and that equals minus 6. We now have one equation in terms of one variable, which we are able to solve. First we must multiply out to get rid of the brackets. X squared stays as x squared, minus x by 2x is minus 2x squared, minus x by 1 is plus x. I'm going to bring the negative 6 to the other side of the equals to give me plus positive 6 equals 0, giving me x squared minus 2x squared is minus x squared, plus x plus 6 equals 0. I'm going to solve this, but before I do that, I don't like to factorize with negative x squared. So I'm going to multiply this equation by negative 1 to change the signs and give me x squared, subtract x, subtract 6 equals 0. I'm now going to solve using my factorization method. Factors of x squared is x and x. The factors of negative 6 that would add to give me negative 1x is negative 3 plus 2. I'm now going to let both of these factors equal 0. X plus 2 equals 0, or x subtract 3 equals 0. Solving x plus 2 equals 0 gives me x equals minus 2, and x minus 3 equals 0 gives me x equals 3. So, the two possible values for x are x equals minus 2 and x equals 3. We must now find two values for y, and we're going to use the linear equation. 2x minus y equals 1. Let us find the value of y when x equals minus 2 first. Given me 2 times minus 2, subtract y equals 1. 2 by negative 2 is negative 4, minus y equals 1. Given me minus y equals 1 plus 4, minus y equals 5, therefore y equals negative 5. Now let us do for when x equals 3. That gives me 2 times 3 minus y equals 1. 2 3s are 6, minus y equals 1. That gives us minus y equals 1. Subtract 6, negative y equals negative 5, y equals 5. So our solutions are x equals minus 2, x equals 3, y equals minus 5, and y equals minus 5. Sorry, that should be y equals positive 5. That brings us on then to our next question. Solve the equation square root of 3x plus 10 equals x and verify our answer. Again, we have an algebraic equation here, only this time it involves a square root. First thing we must do is remove the square root by squaring both sides to give root 3x plus 10 to be squared equals x to be squared. Okay, on the left hand side, the square root and the square simplify to give 3x plus 10 equals x squared. That in turn gives negative x squared plus 3x plus 10 equals 0. I'm going to now multiply this by minus 1 to give me positive x squared. Minus 3x minus 10 equals 0. Again, here we're left with a quadratic equation. We're going to use the method of factorization to solve this. Given us our factors of x squared splits up into x and x. Factors of negative 10 to give negative 3 will be minus 5 plus 2. I now allow both these factors equal 0 and solve, given x equals minus 2 or x equals 5. I've found two values for x. We were now asked to verify our answer. To do that, we must sub these into the equation and check that they satisfy the equation. Let us try when x equals minus 2. Given me square root of 3 by minus 2 plus 10 equals minus 2. 3 times minus 2 is a minus 6 plus 10 equals minus 2. Minus 6 add 10 gives the square root of 4 equals minus 2. The square root of 4 can be positive or negative 2, therefore this is correct. Now let's try when x equals 5. That gives us a square root of 3 times 5 plus 10 equals x, which is 5. 3 5s are 15 plus 10 equals 5. 15 add 10 gives root 25 equals 5, and 5 equals 5. This is also a solution. This brings us on to our next question. Solve the following inequality and show the solution set on the number line below. We have 5 minus 3/4 x is less than or equal to 19 over 8. First thing I want to do is remove these fractions. I'll do that by multiplying every term in this inequality by the lowest common multiple of the denominators of the fractions. The lowest common multiple of 4 and 8 is 8, so I multiply every term by 8. 8 5s are 40. 3 quarters by 8 gives me 24 quarters, which is 6x, so minus 6x. And 19 over 8 multiplied by 8 gives me less than or equal to 19. We now solve for x. Given us minus 6x is less than or equal to 19, subtract 40. Minus 6x is less than or equal to minus 21. Therefore 6x is less than or equal to 21. Only we need, when we multiply by a negative number in an inequality, we must flip the inequality sign to give 6x is greater than or equal to 21. I'll now divide both sides by 6 to give x is greater than or equal to 3.5. Since x hasn't been stated to be a natural number or an integer, etc., we assume that is a real number. Therefore x is greater than or equal to 3.5 and is a real number. So therefore I'm going to graph this now on the number line. So since x is greater than or equal to 3.5, we bolden the number line from 3.5 onwards. So 3.5, and we highlight the number line as such. This brings us on to our next question. Solve x squared minus 4x plus 1 equals 0. Write your solutions in the form a plus or minus root b, where a and b are elements of natural numbers. Now, we've two ways of solving quadratic equations. We can use the factorization method, or we can use the quadratic formula. We've been given a hint in the question. The question says write our answer in the form a plus or minus root b. This is indicating to me that I probably won't be able to factorize this, and I'll need to use the quadratic formula. So, using the quadratic formula, I have minus b plus minus the square root of b squared minus 4ac all over 2a, where a is equal to 1, the coefficient of x squared, b is equal to negative 4, the coefficient of x, and c is equal to 1, the constant. To give x equals minus b minus negative 4 plus or minus the square root of negative 4 squared minus 4 times a, which is 1, times c, which is 1, all over 2a. This gives two negatives here, make 4 positive, plus or minus the square root of negative 4 squared is 16, subtract 4 by 1 is 4. Subtract 4 all over 2a, 2 times 1 is 2. Okay, so I'm going to continue on up here. 4 plus or minus square root of 12 over 2. Now, we can break down the square root of 12, and I'll do it over here. The square root of 12 is equal to the square root of 4 by the square root of 3. And the square root of 4 is equal to 2. So we're left with 2 root 3. Your calculator may do this for you, and if it doesn't, you'll have to work it out like this. So that gives us 4 plus 2 root 3 over 2, x is equal to, or x is equal to 4 minus 2 root 3 over 2. We have a common factor here, 2. 2 will divide into itself once, and into 4 twice, giving me x equals 2 plus 1 root 3, or simply root 3 over 1, which is still 2 plus root 3, or x equals, again we have a common factor on this side, 2 goes into itself once, and into 4 twice, giving me x equals 2 minus 1 root 3, or 2 minus root 3. And our answer is in the form a plus root b, exactly how we want it. Then this brings us on to the next question. Given that 2 bracket a plus b, subtract c equals 0, express b in terms of a and c. Okay, so we have 2 bracket a add b, subtract c equals 0, and we want to express that in b in terms of a equals c. In other words, we want b on its own. We want to make b the subject here. So b equals, and then some terms in a and c. So first thing we're going to do, we're going to multiply out the brackets to get 2a plus 2b, subtract c equals 0. We've removed the brackets. We now want to isolate the b term. We want to get it on its own on one side of the equals. And since it's already on the left hand side, I'm going to leave it there, and I'm going to bring 2a and c across the equal sign, and when they go across, they change signs. It becomes minus 2a plus c. So you can say 2b is equal to c minus 2a. Now, we don't want 2b, we want b in terms of a and c, so we need to divide by 2 to give us b equals c minus 2a over 2. Okay, b is now in terms of c and a. We'll now go on to our last question. 3 parts. Part I. Find a, the solution set of 3x less than or equal to 4. X is an element of z. Z is the set of integers. Integers are positive and negative whole numbers. So we're going to find a solution set here by solving this inequality. 3x minus 2 less than or equal to 4. That gives, we isolate the x term, 3x less than or equal to 4 plus 2. 3x is less than or equal to 6. We divide both terms by 3 to get x less than or equal to 2. Okay, so x can be any integer that is less than or equal to 2. For example, 2, 1, 0, minus 1, minus 2, and so on. It keeps going. Let's now look at part 2. Find b, the solution set of 1 minus 3x over 2 less than 5. Again, x, the solution set, is an element of z, the set of integers, positive and negative whole numbers. So let us solve for b here. 1 minus 3x over 2 less than 5. Okay, I want to remove the fraction, and to do that I'm going to multiply everything by 2. Make everything twice as big, keeps x the same. So when I multiply 1 minus 3x over 2 by 2, I'll have 2 by 1 minus 3x over 2 less than 5 by 2. What's going to happen on the left hand side of the equals is we've multiplied by 2 and a divide by 2. So 2 divided by 2, there's a common factor of 2, goes in once, leaving me with 1 subtract 3x less than 5 2s is 10. Okay, so we now isolate the x term. 1 minus 3x, 10 minus 1, so negative 3x is equal to 9. We don't want a negative, so I'm going to multiply this here by minus 1, and when I do that we're in inequality. I get 3x, I need to flip the inequality sign to get 3x is greater than 9. I'll now divide both terms by 3 to get x is greater than 3. So, since x is an integer and is greater than 3, for part 2 here, x can be 4, 5, 6, 7, 8, and so on. Now let us look at part 3. Find the elements of A intersection B. That N there stands for intersection. Okay? And we should know that intersection means what's common to both of them. So we're looking for the solutions that work for this one and this one together. So we want them elements. So A intersection B is equal to, well, for A, x has to be less than or equal to 2. For B, x has to be greater than 3. Therefore, there's no intersection. There's no value that will work for both I and II. Therefore, we have the null set, which is denoted with 2 curly brackets and nothing in them, or that symbol there.